Yes.
I believe. So are these just going to be added? Are this number 36 going to be added onto this number 36?
Nope, I'm just an idiot. These will need to be renumbered.
Okay.
They should be 37.
Okay.
Thank you for telling me.
Yeah.
That'd be a big assignment.
Was 35 due last class, I think, right?
I did take it.
Okay, perfect. There's that.
Was supposed to turn 35?
35 was from a few classes ago.
So I think most everybody's turned it in.
I'll double check.
Oh, guess I'm wrong.
There's no status. Yeah, but only. Guess what? Yeah, there's a staple over here.
Thank you.
I'll show you a magic trick. Where's the staple? Where's the staple? Did you see my text? No, I'll take my text. I haven't had time. Here you go. Right here. Yeah.
I'm partially owned by the farm.
What? No, I can't make it.
Oh, we're not.
My parents said no.
Why not?
It would be.
Why would they say no? Okay, take the
That's
bus.
because the school still don't let me the house. They got me with 6 absences.
Take the bus
It's all the way
right after school.
Yeah.
Issue bus drivers.
Yeah, but I'm not allowed to like get off and work something else.
Why not?
Because it's how it works. I don't know.
No, the bus lady lets you get off anyway.
No, I have to like scan my ID in and out, like, and if I scan in the wrong spot, I'll be in trouble.
Talk to the bus driver.
What are you trying to do?
Trying to get him to go to the gym after school. And the next one, we walk across the street.
He's just lying to me.
At this point, it's okay.
No.
There's no way they're going to use a crosswalk across it.
I don't know. Ask him.
Tell him to flashing light.
And then put down.
No, you're only using one for each chain. No, they really look like that. We're not lie about that. I want to go.
Hey, you can find
My parents on stage.
It's soon. Just find the solution.
Look at my mom.
I'm gonna go home and totally lay out on my desk with my shirt off. So you're.
That's okay.
So this is. I still believe on Saturday. The worst.
To the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, good morning, guys. If you were one of the first few people in this morning, I forgot to put up there that you need to turn in assignment 35. I was thinking that most everybody had turned that in the last class, and that was kind of like your last warning. But that was actually my 5th period that did that. There was only a few of you that gave me assignment 35 last time. So if I haven't gotten it yet, make sure if you don't see a grade on the top of your paper, still in your binder, make sure you can bring it to me. Secondly, I made a mistake on 2 of the handouts this morning. I'd messed up the numbering. 2 of your handouts this morning say number 36, page 1 and 2, I believe, but you already had a number 36. So I need you to change that to number 37, page 1, and number 37, page 2. It's just 2 pages, correct?
Yes.
Okay. So you need to do that right now, please, because in a week or a couple classes from now, if you get that mixed up, that's still on you. I'm giving you time to do it right now, please. The 2 handouts you picked up this morning that said number 36 should have both said number 37. You already had a number 37.
Should number 37 say number 38?
Yes.
Got it.
Yeah, and sorry, just to kind of dominoes. This is why I'm
Well,
skeptical.
Staples. They're all out of Staples.
I'll just write my name on it.
It's fine.
Oh, you're the second for the Staples. Okay. All prepared for the Monday.
Well, not really, because we've already corrected 3 things. But okay, so the assignment, the 2 papers you picked up this morning, both that say 36, page 1 and page 2, need to say number 37, page 1, page 2. The one that says 37 needs to say number 38. I apologize. I must have forgotten about one of those handouts. Okay, so we are not going to move forward too much today. I feel like some of the polar stuff we've been doing is some of the hardest stuff we've been doing this year. So that's going to buy us some time to get more comfortable with what we've been doing. So first thing I'd like to do is I want to at least start you on the last part of polar. So I guess I need to fix this up here too. So these are number 37, so this is 38. Is it correct on the board now? The 2 pages are 37 and the other one's 38? Yes? Okay, great. So I want to start you on the last leg, especially, well, you guys know I've been doing this for a while this year, where I just kind of start you on a lesson and then we come back and review it. I just think it's good for you to see it a couple times, and then of course, if you're struggling, it gives you the opportunity to work ahead a little bit to try to get ahead of everybody else. So we're going to talk about that, and this will be the last of the polar units, but it's kind of building upon some of the other stuff, so I'd say it's probably one of the harder ones. And then to take a step back and to build up a little better foundation here, number 38 is one of those short assignments that's really just extra practice. It's 5 questions, and these questions are back from our very first polar lesson. So you should feel much more comfortable with these now that we've done a couple classes on polar. So I'd really like you to try those 5 without notes, without a calculator, except for number 5 because it says it's calculator active. And just make sure that you, if there's some basic in there that hasn't clicked for you yet, you at least identify that and get it caught up today. Okay, I will ask you to turn in assignment 38 today, because again, it's just 5 questions, and after I introduce number 37 to you, that would be your next priority. And then instead of asking you to turn in assignment 36, I'm just asking you to continue on it. So we started it last class. Some of those questions, I guess we started it last class, but some of those are pretty tough. So I want to give you more time in case that has been a struggle for you. Okay, so before we start looking at assignment 37, is there anything you want to ask about today's agenda? Okay, so to start off here, we are still talking about area with polar. So we're still going to need this formula from last class, which was 1/2 integrating from a to b or alpha to beta r squared d theta. That's the new area formula we were looking at last class. But instead of just trying to find area or part of an area within a polar curve, we're going to be trying to find the area bounded between two polar curves. So it's not that the calculus is really that much harder, but we have to investigate each question a little bit deeper. So as we work through this, you need to actively be thinking about, sometimes you need to find points of intersection, like where two of the polar curves intersect each other, and to make your life easier, symmetry. There's a lot of symmetry in these, so sometimes you can just do one part and then double your answer, or do one part and quadruple your answer, and it makes it a little bit easier than doing it the other way. Okay, so for question 1, find the area of the region common to both of these curves. So, of course, graphing these are not as easy as just graphing stuff in rectangular coordinate, although I guess you could maybe convert it sometimes. But just for time's sake here, 4 times cosine theta is going to be a circle that is on the x-axis, cosine, with a diameter of 4. That's that one. Whereas 2 sine theta is going to be a circle with diameter 2 centered on the y-axis because it says sine. Again, you don't really have to memorize those shortcuts or anything, but it's like that. So we are going to try to figure out, well, how much area is there that's trapped on both of those? So we have to use quite a bit of reasoning skills to think about which part of which circle we want, so we can either do this in parts or maybe find one area and subtract one area. There's not going to always be the same process. So for this question, kind of emphasizing here, points of intersection. Both of these intersect here, well, at this point and at this point. This angle, well, maybe I shouldn't tell you this angle yet. Talk about how to find it. Okay, so I'm looking at this and I can see I want part of this curve and then like part of that curve. So if I take our formula, we can say area is 1/2 and then integrate. So for this red one, I can see that if I start at 0, again, if you have a table for when you graph these, it's a little easier to see. But if I start here at 0, I would like all the angles that go up to here. So 0 to wherever these intersect. So to figure out this intersection, because this is some random value that you're not going to guess, you could set this r equal to this r. And then you can solve. You could divide both sides by 2. I divided both sides by cosine. And so that is where tangent is 2. Now, that's not a common unit circle value, so I had to, in my calculator, say what is the inverse tangent of 2. And it tells me the angle that those intercepted at was about 1.107. So about 1.107. So I want a very limited range of angles here, from theta equals 0 to here of the red line. So I'll do this part in red, or I'm sorry, the red polar. So since it just needs to be r squared, and I'm looking at this one, this would be sine theta squared. Okay, but then we need to add, I'll make sure this 1/2 is out front, so it's not just doing half of this one. Then I want from here to pi over 2. My picture doesn't look the best there, but from here to pi over 2 in the other function, which is 4 cosine theta, so it's r, up through pi over 2. And then when you add those together, you end up getting, I don't know, you'd have to have a calculator for most of these, but about 9617. So most of these questions are going to be just like this, where some of it's not too bad, but trying to reason through and think through, how am I supposed to find the area of this? Maybe I'll take part of this one and then part of that one.
What's your upper bound of pi over 2? How did you determine that it was pi over 2?
Okay, so if I probably should have zoomed in here, but there's really, some of it's hard to see because my picture isn't the best. I maybe should have done this on the graph, but really there's like a line right here. So that first part was just from here to here to this intersection point. And then for the rest of this curve, you see the big, the black circle one? So there's a little bit more. So I wanted to start at this intersection point and take all of its area up through where it would be pi over 2. It looks like pi over 2 is here, but pi over 2 is on this curve, so it's actually this. So that's how you get that extra little sliver. So the intersection to his pi over 2 gets this other little sliver. So again, the better your picture is, the easier it is to see, and this was a bad example, so maybe you can at least learn from that. But basically I'm saying for my red one, I want this part of the area, so that was one integral. And then on the black polar, I wanted this part of the area, so I just basically did 2 areas. And thinking about when do I want to start and stop for that one, and when do I want to start and stop for this one, is just takes a lot of reasoning, so it just takes a lot of practice.
How'd you know it was pi over 2?
Because that's where pi over 2, this is where pi over 2 is for that one. It's where r is 0 on this one.
Oh.
So if you set this equal to 0, the next time that's going to be 0 is when cosine's pi over 2. Some of that, again, I'm not trying to gloss over that too much. It's just that that's the part that you're going to struggle with, so that's the part you kind of have to dig into. That being said, I think you will be a little more comfortable with the intersection points when you graph it yourself. Because when you graph these two yourself, you're probably either thinking about like a table and you've got a few values in front of you, so I don't think it will be as bad as it looks like there. Okay, so we're going to just look at a couple more of these, a couple different strategies, but again, ultimately, we're just doing area between polar curves, but sometimes we want part of this curve and part of that curve. So we would take part of this curve plus that part of that curve. So that's one approach. Okay, so on question 2, they want us to find the area of the common region of the polar, these two. So this one's nice because at least they graphed it for us. So I'm trying to figure out all this area, and so you could do this kind of like we did the last one. You could maybe set up, I want this part of this one plus this part of this one, and maybe that would work. But also, do you guys see the symmetry in this right here? Do you see how this amount of area is equal to this amount of area? So I am going to choose, and this is totally optional, but I'm going to just choose to find this much area, and then I'm going to double it, just because I think that's going to make the question a little bit easier, at least easier to me. So instead of saying the area, well, I'm going to say half the area. I'm not doing the area formula. I'm taking half the area that I want. And then I need to think about how to find these pieces and what part of each one that I want. Okay, so I'm going to zoom in here and I'm going to color these so we can talk about these polar curves a little bit easier. But here's the red polar curve, and we'll do blue, the blue polar curve. Okay, good enough. Okay, so I'm going to help you see this one, but if I want to find all of this area, one part I would like to find is this. So, which one of those two polar curves would I be more interested in? The blue or the red?
Blue.
The blue, okay? So I'm going to be working with the blue. And so if I want to find this much area of the blue, I could do 1/2 integrate from something to something of r squared d theta, but the blue is r equals 2. They gave me the equation for r, so that's easy. So just focus on this part of the area. What angle should I start at and what angle should I end at for that?
3 pi over 2 is 2 pi.
This is, I'm sorry, wait. I heard a couple different things, I think.
3 pi over 2 to 2 pi.
Minus pi over 2.
Okay, that's fine. You could say 3 pi over 2 to 2 pi. That's fine also. I just said negative pi over 2 to, if I do negative pi over 2, what would be my other one? 0. Okay, so that gives me this highlighted part. Now again, I'm trying to help split this up to help you see how to dissect this, but I also want, add to that, this little piece of area. If I'm trying to get this whole thing, and then I'm going to double it to get the answer to this question. So his area is going to come from the formula 1/2 integrate alpha to beta r squared d theta. And for the red polar, his equation was r equals 2 minus 2 sine theta. Now, of course, if you don't know which one of these is r equals 2 and which one is r equals 2 minus 2 sine theta, you could just plug in a couple angles. Like, some of them only land in some places. As long as you don't plug in these angles, it should be fine. Okay, but the hard part is, now I got to think about, just focus on this red polar curve. I want to start at this angle, and what angle would this be that would give me r is 2? Okay, and if you aren't sure, just plug it in. 2 minus 2 times the sine of 0 would be what? 2, which is what it's supposed to be. This radius is 2 when it's plotting in that direction. So I want to start at 0, and then I want to keep going till r is 0. And what angle do you think that is? Okay, pi over 2 is a reasonable guess. But make sure, if I plug in pi over 2 here, I would get 2 minus 2 times 1, which is 0, and it is 0 in this direction, so that makes sense as well. So when I take
How do
this,
we know it's 0 in that direction and not the other direction?
sorry,
How do we know it's 0 in that direction, not doing all the way around the circle the other way?
in this way?
Yeah.
Why would you go this way? I don't understand why you would want to go this way.
Well, I don't want to, but couldn't you do that? You know what?
I'm sure it's possible, yeah. I don't know why you would. Each one of these has a ton of different ways you could go about this, I'm sure. You could also just try to find this whole area, and you could maybe do the red from 0 to whatever this is to get this top little piece, and then you could do the blue from here to here, and that would be fine too. But I'm just trying to split it up in a way that I think makes sense to y'all. Okay, so this, let's think about what our two parts are here. This is the area of just the blue polar from negative pi over 2 to 2, plus now we're adding the area of the red polar from 0 to pi over 2. And again, I didn't instantly know this was 0 and pi over 2, and sometimes those are tricky, but I kind of showed you how you can check. If you think the radius is supposed to be 2 when r is 0, or when theta is 0, plug it in and see if it is. If you think r is supposed to be 0 when theta is pi over 2, plug it into r and make sure it is before you assume that that angle is pi over 2. So you add those two up, you get all of this area. So what we would want to throw into our calculator is let's do 1/2 from negative pi over 2 to positive pi over 2 of 2 squared plus 0 to pi over 2. I've factored the 1/2 out front. Both of these have a 1/2, but I factored it out. Of his r d theta. And if I throw all of this in the calculator, that is going to give me about 3.854. Okay, that's not the answer though. Right, so if you're gonna just do half of the area, if you can see some symmetry and you just wanna do this half and double it instead of trying to do the whole thing, make sure that you remember and don't forget about that was really only half of my answer. My answer is double that. So just be careful if you're using that symmetry to not forget that you didn't find the whole thing. So second question, still the same area integral that we started talking about last class that I'm going to give you more time to work on today to get better at. But thinking about what part of each one you want and what the intervals would be to each one, you can see it's not the easiest. Okay, let's just do 2 more for today, and then I think you kind of get the point, and then you can dig in deeper on Wednesday. Okay, find the area of the region common to the 2 polar curves. So I'm going to color these again so we can talk about them a little bit more easily. This is this one, and this is this one. Again, if you are not sure, just plug in a theta into both of them. One of them is going to have the right radius and one of them is not, unless it's a place they're at the same place and time. So the shared area is all of this. This is what they're talking about, common area. So both of those overlap here. You don't have to do what I'm doing here, but I just found this half and then doubled it at the end just so I have less to worry about. So before I forget, I'm not saying A equals, I'm going to say half of A, half of my answer, half of the area I want. And then start going through and thinking about which part of which one you want. So, any ideas when I would want, let's start with the blue one. If I do 1/2 all of these, if I start with the blue one, that would be r squared d theta. But from what to what do I want? Okay, so I'm purposely making this one a little harder on you. If you kind of zoom in, which you're very limited to do, from right here to right here, there's like this little intersection line. And that kind of helps me see how I need to split this up. For the blue one, I just said, let's see, what was my blue one? I want where well, you certainly have to figure out this intersection point. I don't remember the order I did this in, but this intersection point, you could just set 1r equal to the other r. And cosine equals negative a half at 2 pi over 3. That's how I figured out that this spot where it stops being one of the polars and start being the other is 2 pi over 3. So I actually need that for both of my integrals. Okay, let's actually do the red one first. I think it's just a little bit easier to see, or maybe that's just me. But for the red one, I want starting here, and then as he turns, he's the one that's going to create all of this area. So from 2 pi over 3 till I get to here, and what do you think this angle is? Okay, pi is a good guess, especially since it's straight to the left, but don't assume it's pi, because again, some of these are tricky, especially when they start looping and stuff. So you can plug pi into his r formula, and you would get 6. So if you're going in the pi direction, he should have a radius of 1, 2, 3, 4, 5, 6. Okay, so for the red area here, I want to start at 2 pi over 3 and end at pi. Oh, I'm sorry, that's actually the blue. I lied. This is the blue. See how it's trapped in the blue and not in the red? The red would actually be all of this. I'm sorry, I said it backwards. I just want this blue area that's trapped in this blue polar. So the blue one is from, what did I say, pi over 2 to, oh I didn't, I said 2 pi over 3 to pi. Okay, plus 1/2, which has been factored out, integrate the other r. So I know what r is, it's really just the bounds we need to be careful about. So the part of the area that comes from r is this stuff in here. So I would say we're probably starting at this theta and ending at this theta. So I've already figured out that they intersect at 2 pi over 3, so I've got that one done. But what would you think this theta is going to be?
0.
Okay, and then we can try it. The sine of 0 is 1 times -6 would be -6. Does the radius look to be -6 in length if you're going in the 0 direction?
Yeah.
You're right, it does. But that's not what I got.
What is it?
I said pi over 2 to 2 pi over 3. What was I doing? 2 pi over... Oh, okay, so yeah. If you pick out 0 to be theta, of course that point's going to be on the graph, but it's this point. I don't want to start tracking area right here. It's getting me a bunch of stuff that I don't want. So, sure, 0 is the place that you might think of, but that's not the angle we want. We actually want to start where it's starting this area here, which is this. So we actually want to start at pi over 2. If you plug in pi over 2 to this, you get 0. So at the pi over 2 direction, he has a radius of 0. But then from pi over 2, how much am I turning from pi over 2 to 2 pi over 3? That's how you get the red polar area that I wanted. So pi over 2 to 2 pi over 3. Now, don't forget, I just did half just because I thought it would be easier, but I really wanted all of this, so make sure you, whatever this comes out to be, you still need to double it in the end. It's about 15.708. So I know your reasoning skills are good enough to think about this part plus this part is the area of the whole thing, and I know you understand if this is half of your answer, you could just double it. But the big thing about this one that I really hesitated on and gave you all a second to try to see if it jumped out at you, you sometimes got to think about how to dissect this. You probably didn't see this line or think about this line, but some of this came from one of the polar curves and part of it came from the other polar curve. And if you don't think about this line, and if you don't think about where it stops being this area and starts being this area, 2 pi over 3, then you're going to have a hard time getting started. Okay, let's look at one more here, and then I'll give you a chance to see if there's something I can quickly clear up for you, but we won't worry about this until Wednesday, but at least you'll have seen it. This one's definitely the easiest, in my opinion. If you wanted to know how much area that is, you could just find the area of this whole thing. I'm going to call this R2. And then you would just take away the area of this stuff. I'll call this R1. This is radius 1, this is radius 2. And of course, if you're taking this whole area, which is this stuff, and then you're taking away the area that's that stuff, it's going to leave you behind the difference between those, the area bounded between those two curves. And of course, since these have the same bounds, they both have a 1/2, they're both d theta, ideally we would just want to scrunch these into one and just say R2 squared minus R1 squared. Just a little more concise. So you just find the big area and then subtract off how much area you don't want to include is basically what it amounts to. Okay, so for the next question, since we're only going to look at one more of these today before I give you time to practice some of the back skills, I do want to kind of make sure we're all on the same page, but I want you to put some thought into question 4 just to see if you are on the right track or if this is something that you'll need to put more effort into. So for this one, let's go ahead and just agree we will all find this area and then double it. So before we forget, let's say we only are trying to find half of the area to start off with. Okay, which one of these two is going to be r equals 1?
The y one that's equal of all
Circles into
the big circle.
This one?
Yeah.
The one where r is 1. The circle where radius is always 1. So that must mean this is this one. And again, you could plug in a couple thetas if you were still not sure to see where the points lie on which ones.
You should find the area of the red circle and then subtract the area of the purple circle from the red circle's area.
Okay, I like the subtraction, but when you say the area of the red circle, do you want all of the red circle?
I just want that small little corner of it.
Okay, so let's do the area. I'm going to do 1/2 out front so I don't have to put it on both. 1/2 integrate from something to something of r d theta. So we're looking at the red one first.
0 pi over 2.
Okay, so you think this is 0 and you think this is pi over 2. I think you're probably right, but sometimes these are tricky. So let's plug it in. If I plug in 0 into this, I get r is 1 because you can't even plug in a theta. So this distance is supposed to go 1 to the right. Check. If I plug in pi over 2, there's no theta to plug it into, so it's going to be 1 at pi over 2. You go pi over 2 direction, the radius is 1. So 0 to pi over 2. Now, the problem with that as our answer We can't just plug this in our calculator and double it, because if we integrate the red polar from 0 to pi over 2, we're not just getting this stuff that's highlighted, we're getting all of this area. So this is where I was saying I'm glad that he said subtract. We want all of that area, subtract this area. Y'all see that? Okay. So subtract 1/2, which has been factored out front. This guy's r squared d theta but from what angle to what angle is going to give me this curve area. Okay, what do you think r is here at the beginning?
0, 0.
Okay, when theta is 0, r is supposed to be 0. Okay, if we do that over here, if I put 0 in for theta, does that mean that r is theta, or r is 0 too?
Yeah.
Okay, so that makes sense. We could start at 0. And then what would you guess this to be?
Over 2.
Okay, and we can look at our graph and see that the radius is supposed to be 1. We can measure the radius here. So if I plug that into his polar equation, 1 minus the cosine of pi over 2, does that give me 1? Okay, so then it must be pi over 2. But I really think you need to do that check, because again, sometimes with polar, you know, it might be in the 2 pi over 3 direction, but if r is negative, it's actually plotting the point behind it or something. Okay, so I'm going to throw all of that in my calculator carefully. Some, of course, like this would be pretty easy to do without a calculator, but and I get an answer of this, and why should you be concerned about this as an answer?
Still only half.
Okay, except that I remembered to double it in my calculator, so it is correct. But yes, you need to make sure that you double it. Because again, I chose to just find this highlighted area because I saw the total would be doubled at. If you would rather, you don't have to double it at the end if you want to find this whole thing, but then you're probably making the setup more difficult. So. Okay, so it's still largely the stuff we were talking about last class, area under polar curves, which I'm going to give you more time to practice. You can see we're going to be using it even more on Wednesday, so it makes it a little bit more important. But for today, I think that's enough introduction. Is there anything that is just any burning questions about this that you would want to clear up in your head? Okay, so the next thing I'd like you to do, number 38, was this one Miss number 2? Yeah, so the one that was numbered as 37 actually needs to be number 38. Again, I apologize. So that's just 5 questions, and this is from our first section of polar. So now that you've got a couple classes of polar under your belt, these should be significantly easier. But again, please use this kind of just as a self-little check to see where you're at and what you actually know and what you would actually have to revisit before a quiz. So the answers are on the bottom. Please try to do it without your notes, without your friends, except for question 5, a calculator. And you know, obviously if you get stuck at the end, I would rather you get some help from me or from your neighbors or from your notes. But you need to put a star by those questions, because if you still don't know that or know what the approach is supposed to be, then that is definitely something that will need more attention as we move forward. So I'd like you to do those 5 questions. Feel good about that. And then continue on assignment 36 from last class, where we were talking about area of polar curves. So try to get some more of that done too. And again, the better you understand that assignment 36, the easier assignment 37 should be on Wednesday because it's still area, polar curves, it's just parts instead of whole things, so. Okay, I am going to put these homeworks in gradebook, then I will pass those back to you, and then I will be available to help out with whatever questions you might have. Also, keep in mind that there's only 3 polar lessons. So the one I introduced to you this morning is the last polar skill you'll need for this class. So. That's your Halloween stash? If it gets too hot, you'll have to turn that off. Okay, I passed back all the homework. There was 2 no-name papers, so if you gave me your hard copy this morning and you didn't get it back, it's probably one of those 2. You need to come see if it is and claim it if it's yours.
That's fine.
Liam, you can keep it. I got the score in now. Mason, I don't have yours.
Not mine.
I think this one's fine.
Do you have mine?
I do.
Okay.
You must have turned yours in last class.
Do you have mine?
Sorry?
Do you have mine?
You came in late, so you didn't turn it in yet. Huh? I said you didn't turn it in yet because you came in late. You didn't hear my reminders to turn it in. Also, this homework that most of y'all are turning in this morning, this assignment is the same topics as what you're practicing those 5 questions on. So if you really are stumped by one of those 5, eventually you need to look at that handout to maybe get a reminder about what the process was. the 36 is one I'm giving you more time to work on at the very end. That's probably the hardest thing.
Mr. Johnson.
So that's theta prime is 4. That's theta, not theta prime. Theta prime is the rate that theta is changing, how that goes. To get theta prime, you need to take the derivative of this with respect to time. So the derivative of r with respect to r would be 1, but the derivative of r with respect to time would be r prime. The derivative of constant 0. The derivative of cosine something would be negative sine something. But since you're taking the derivative of theta something with the derivative with respect to time, those are different variables, so you need a theta prime there, and then that's the same as implicit. I think we said this last week. Yes.
I know you have one question on it, though. On the 35.
Really nice. So when you first learn derivatives, you do everything with respect to x.
Yeah.
So do the power rule, you bring the power down, you lower the power by 1, and since this is an x, you're taking the derivative of an x thing with respect to x. And this is essentially times 1, which is why it doesn't matter. But then when you do implicit, you still do the regular old power rule, but then you say, wait, I took the derivative of y with respect to some other variable, so I need a y prime. The same thing with you there. You're taking the derivative of theta with respect to some other variable, so you're going to get a theta prime, which is where that 4 is coming from.
Okay.
Oh, okay. It then just didn't save then. You already got a score on it? Oh. I'm sorry. Oliver, yours is already, I had your grade in. I just missed what. I'm sorry.
So how it is trying to drag your students' reputation to the wall. What did you get from the back of this paper? Did you get anything from all of this? Or something completely different? What did you get from the back of this sheet? Just on every question. Just find the areas.
You ready for that physics test, Brad?
What?
You ready for the physics test?
No.
Ooh, on physics test today? Yeah.
Competition?
Maybe I'll get a 40% average this time.
Or do you think that is just going to remain a sneak peek and totally pointless to put on the test review? Do you think it's actually going to be regular physics on the
I think the test review is going to be way hard to roll back.
do you think he's going to give us a whole test, a whole class area to do what?
Last year they went to Grand Nationals.
Probably not.
I mean, you could do this, I guess.
They'll probably like
I did the first question.
give us as much time as we want for the test and ask us what we want to do.
I'm not complaining. That's good.
It's like the least structured teacher I have.
I do have a leadership position.
How's it going?
Good.
Yeah?
Yeah, we
You're on
can-
question. We did this together.
Yes.
Yeah, where's yours?
That was, oh, there it is.
You really did. He went over to Running City and did up all his things.
Brendan, were you the one last year where I like hid your paper and you started redoing it or something?
Yes.
That was you?
I redid the calculus before you found it.
It's a waste of your freaking notebook.
That was good
All
for
you
you.
don't waste your freaking notebook.
Like, it wasn't a very hard thing.
That was-
So I was doing clean
Oliver, why would you buy a notebook for your study hall? Don't waste your notebook.
That one doesn't have state rep.
Turns out it's like just one
Yeah, I'll do like ticket here.
Oh, I have one notebook for all of my classes.
Literally the only thing.
It's the same notebook I used for AP Chem last year. I don't even have it with me, because I don't need it on ADA.
So that's whatever verticals or X prime is.
I've got two binders for 3 classes.
Mr. Johnson.
A notebook for a third. A notebook for a
Is that what it looked like when we take our
Horizontal is 0.
You're saying because the bed is in there?
Yeah, one is where
Exactly
another
right.
and one is where
Yep.
not.
Yeah. And then that's why they're giving you things.
No, I.
If you're trying to solve for
So I looked up right at the start.
R prime, so there's this R prime. They're giving you a theta prime, so if you had an equation without a theta prime, it's probably wrong, unless that's a distractor, which is kind of mean, but it's possible.
And then whenever they give you theta equals pi over 3, theta prime is just 0?
They're talking about is theta.
Oh,
Theta
so-
and
Oh,
theta are two
right.
different
So
things.
theta prime is just 4.
Me is where something is.
Yeah.
Designates the object.
Maybe plugging in pi over 3 and
It's also.
Yeah.
If someone says something, it's designated.
No, right.
Or if.
No, square root of 3 over 2. That's right.
If you say something.
'Cause that's over
it's
1/2.
total BMS or total.
Number 7 squared equals 1.
It's whichever the larger one is. There's 1/2, and then there's square root of 3 over 2. This is 2 functions, right? Well, yeah, obviously it has to be.
So it has to be square root of 3 over 2.
Equals 8 sine times another sine is another sine.
It's not.
Is that a good answer?
I forgot, that's how it works. And then whenever you have your pi over 4 values, it's just square root of 2 over 2, cos square root of 2 over 2.
Yes. Whichever one's gonna be negative.
Negative 2 sine. So then, what is the value before 1 squared is 3? 4. You have 0 something, pi over 4. Pi over
0,
3.
pi over 6, pi over 4, pi over 3, sine 2.
2 pi over 6 is square root of 3 over 2. Square root of 2 over 2.
Yes.
When do your 1/2s come? When are those?
No, it's square root of 3 over 2, up. Square root of 2 over 2 only applies to the ones that are rationals.
Gotcha.
Pi over 4 pi. Would that be 2 pi over 4? Things like that.
That's right.
Okay, so we're just fine on prime, right?
Yes, it's very convenient like that.
Oh, no, we don't. You know what?
We need to find dy over dx. So we can find y and x equal.
We did, dy over dx. Oh, wait, it's a 2. That's your slope.
Well, I'm pretty sure there's a chance.
How to find dy over dx. Tangent.
Because, 6 divided by 3
y
equals.
over x.
I thought you found the
So
slope.
yes, reverse
Slope,
place.
dy over dx.
Which means you have to go through this, just a long process.
It goes through a big one, this too.
Well, yeah, that's what it is. Do R sine theta.
Well, I guess you
R
multiply.
cosine theta.
And
So your y would be 3 sine squared at a grade.
Yes.
that is not the answer.
I got two.
Now you take derivative of that.
Wait, no, I got a lot of stupid equations that make up. It's also cosine well, it's sine squared, that's why. So you square those, and if you take the square root, it's
Nice.
the square root of 1/2 is 1 over square root of just square root is 1 over 2.
Oh, no.
That's why.
No, I already did that.
That's what we're trying to find.
I was reading it, but I was a teen, and I was betrayed by my allies. And also I
Here.
allies, but my allies died. To graduate. The police, by the police, I mean, my colleagues betrayed me.
So to find the instantaneous rate of change, isn't that just you take the derivative of r?
Yeah. I got betrayed, I betrayed someone, and also I killed a
Mr.
man.
Townsend?
Yeah.
The instantaneous rate of change of r, isn't that just take the derivative of r?
Yes.
Okay.
Which one are you looking at?
4.
Oh, yes. Yeah, just take the derivative of r.
So it would be,
It's a good thing you know the derivative of cosecant.
it's negative secant.
No.
Negative cosecant secant. I mean cosecant.
Sounds like this needs to go on the next quiz again.
Okay, negative cosecant.
You could derive it on your back page.
I'd rather not.
And then, I looked up my own, across the body of water, I think it's a seed that might have been just straight or something.
And then you plug in pi over 4.
So I was thinking water or something, or eating, I remember, oh, shaggy, right?
Well, I have cosine squared over cosine squared here. But I still have this.
What'd you get for
We're trying to find the vertical tangent, right? Yeah, I mean, it's undefined, so we're trying to find when this equals 0 equals
But you got 3 cosine squared.
So cotangent pi over 4 should also be 1, right?
It should equal what?
Which always equals 1 because you can't.
Yeah.
Okay, you guys have about 30 minutes left.
Something like.
Well,
Oh, but there's an answer.
Inverse.
How many rules?
Well, it would still be square root of 2.
This is
Okay, so then what's
okay. Well,
Keep going.
cosecant is
therefore equals.
well, it's the same as 1 over 1.
Oh, because it's minus.
imagine just because it's a plus and a plus, but they're the same thing, so it's like 5 minus 5.
Which is 0.
2
versus
The same, negative 4 and whatever the negative one was.
Yeah.
Negative pi over 4 cosecant. Cotangent of pi over 4
The point
is
is, I stole all of the food that I made.
cosecant of pi over 4 would
And
be
some bugs and cheese that were not.
1
Well, I'm gonna write that
over
down.
1.
So it doesn't matter if your value is negative. You know, you're thinking about doing 5 power 4
Yeah.
because one computer said that y value is negative.
Yeah.
But that doesn't matter because you're squaring it. Because you have your negative, because you have your negative right there. So they just have to be the same. And
And then also, why not
So it should be all power 4
all of pi over 4 values?
Cosecant plus -2, not -2. What is it?
I guess the graphing utility eliminates the other ones.
Because the derivative of cosecant is negative cosecant cotangent.
But then, does not be multiplied by 3. This is after.
It is.
Trying to change triple after.
Okay, so the derivative of cosecant is cosecant, negative cosecant cotangent.
Yes.
The only difference is 2 of 5, so it's negative 2 cosecant cotangent.
Arkansas? Yeah.
Highly disappointed. Cotangent's on negative.
Okay.
Yeah, it doesn't really factor in.
So, say the cosecant is just x.
I mean, it's nice to put
2x, the derivative of 2x is, you just ignore power rule. That's not basically what it is. It's just 2x. You substitute in the cosecant. 2 derivative of x.
You get the right answer.
Yeah.
Okay, so it'd be
What is cosecant?
negative 2 parentheses, negative 3.
No, it's just 2 parentheses negative cosecant cotangent, or negative 2
In
cosecant
any case,
cotangent.
then, somebody else,
It'll be a
other, it would have been a
Yeah.
man.
What'd you get for 3?
That they were on the triple.
Pi over 4, 3 pi
And
over
then they
4.
ran through the streets of Fayetteville trying to escape whatever.
Thompson, you know the answers are on the bottom, right?
Oh.
And it turned out that Fayetteville
I
was
forgot.
on the coast being highway
That helps
which I already
You
knew
forgot.
because I crossed it to get to
Got
I was
it.
looking to
The sun.
Can you tell me where we're at with the daily puzzle?
You've done this?
Yes,
Yeah.
we've done that.
Sine of the negative 1 theta was the same thing.
We've done this on that, yep.
When there's a cosine.
Is what?
Cosine minus 1?
Oh, I
We haven't done this yet.
It's not the same thing as saying sine of negative 1 is not the same thing as saying cosecant of 1. Just 1 over sine is the same. I know that you would normally say, right, sine, negative 1 is 1 over sine. That makes sense.
I'm sorry, what
But I
is
think
a
they're asking
rectilinear
for
shape?
different things.
It's a rectilinear.
Yes, it's what I talked to
Ooh,
him
I
about.
don't think we can say that.
Rectilinear.
Because cosecant of beta is not asking for, it's not where you're plugging in your value, searching for your angle that correlates to that value.
Well, 1, 7, and 1's like 5.
Well,
9
9 plus 9 is
Sine of,
5
yeah, sine of
plus
negative 1 is
7.
where you have your value and you're looking for your.
How does that equal that?
Hold on. Well, because Thompson, if you look,
no idea.
we can find all of the sides of this side, because it's just 9 and then 9 on the right side as well. Every single one on the right
Wait, no,
side. So the issue is just finding a little bit on the top and the whole thing on the bottom.
I heard that when I go to the bathroom, you start sniffing some lines.
Wow. That's the end to life, the inverse of everything.
So the,
Giving my sources up.
How's that?
Did you say-
No way, no chance, no chance.
I still have a chance.
Timmy has a chance.
We got Braden
So
1.
it should be 5 to 7.
Braden won?
Yep.
How?
So yeah, I'm 100% sure it's 40.
Win the competition.
Once I did math.
competition.
You gotta remember
Playing
this.
dumb.
Come on,
Actually, skates
Braden.
one competition.
I didn't do
We
it.
talked about this all last week, Braden.
Braden.
I don't remember.
How can you remember
Braden, you
the
want a
origin
reminder?
of cosecant, but you can't remember what we were talking about?
No, you see, because I don't actually do my work instead of paying attention to your.
Oh, Bubex.
Well, you were part of the game. So.
Was I?
Yeah.
What
were.
game?
Liam, tell him.
I don't know what you're talking about.
Oh, now we're gonna think I'm playing dumb.
I'm gonna get in trouble.
See, everyone in here knows,
Braden.
aside from those two, apparently.
Why do you know it? Why don't you say it?
Was it to see if you get a girlfriend first?
Oh,
Yeah.
no.
Hit it on the head.
Context clues.
Did Braden win?
I did, yeah.
No way.
No way.
You have a
I
girlfriend?
mean, I'm not surprised, but like,
Dude,
I'm
what?
sad. I'm sad. I didn't.
Over the weekend?
Halloween.
Dang, what happened? What happened?
Talk to it.
Don't have a piece on the story?
She came over to my house.
With no parents home.
With no parents home?
No parents home.
There were parents.
No
home.
parents.
There were parents.
There were
Netflix
parents.
and chill.
That was not.
Oh my
So then
god.
what happened? What happened? What happened? What happened today?
We just hung out.
Just one-on-one?
Hey, do your work.
Why'd I get 1.12 for
I heard there's a lot of people knocking at your door.
Yeah. Yeah, I heard about that. I didn't know at the time, but apparently my neighbor was pounding on the door asking questions about me.
Why?
It's a great question. It's 'cause it's
Y'all were having a
smells.
rager? Y'all were having a rager?
Just in the room.
Shoot. Timmy, what are we doing?
Well, I don't know, bro.
Neighbors again.
Brandon, need advice.
The advice, Brandon? Yeah, what?
Give us
How'd
advice
you
so I
bag
can
that?
do it.
How'd you bag that?
Okay.
I mean, when you're as cute as Brandon, it's just too easy. Dyson is devastated.
That was a quick conclusion to the competition.
It was. Okay, now we're playing for a side pot.
So it's
Your second place.
Second.
Oh my god.
Bobby versus Dax.
Wait. Thompson versus Dax Flynn. Can I borrow your calculator?
Thompson, what's your
Dax,
first
we gotta
strategy?
we gotta level the playing field. You have to act like Dax Flynn. I don't know. I've opened it up since the beginning.
I think he gets them better. I think he makes that would actually increase my chances.
Should we tell Mr. Townsend that Brandon won the call?
Yes, we
Yes, we have to. Brandon, that's crazy. Where are you at, Mr. Townsend? Where you at?
Well, I can't.
trying to avoid us.
Polar form makes me want to shoot myself.
Polar form is definitely hard form to the 7.
So we think cosecant.
I don't know what number 3.
Yes.
Yeah, I'm gonna look at Brady's.
Yeah, I skipped 3.
Oh, the 7th. Garden. Food.
2 is actually but
Oh, yeah.
what does it say? So it's find the value of the derivative of r with respect to t. So I just took the derivative of r, so 4 terms of 0, and then
For some reason,
negative
I
cosine of theta equals to 2 sine of
Don't we
theta.
know the derivative
And
of
since with
cosecant
respect to
is
t,
negative
you
cosecant
do,
of
October.
after you write 2 sine of theta, you write
I had some other
d
plans that
theta over
so much
dt.
with the rock, so I thought, damn, I'm gonna have to cancel.
Yeah,
Does that make
that's
sense?
it. That's it.
But it turned out wrong.
Or I don't know if I can fully understand it, but I understand how to do it.
So it's
I
minus
think
2.
Dax can understand right now.
Yeah, but
Where?
No, I missed it.
It'll still just be like
I'm just gonna wear my jacket, a t-shirt, and sweatpants.
I don't actually know if I want to.
We gotta
Also
multiply
have
it by
that
sine
sign.
now. At the same time.
But what is that sign? Product. Chain rule, chain rule.
Rat dog.
No, we do chain rule.
Okay.
Look. Set it up like this. Now sign's on the outside. So now it's
No, because I got
cosine
one.
of this. Multiply by this.
on the line.
All of it.
0.
The only thing that attempting anything at that point is going to do is give me a panic attack. I'm gonna be honest.
Come on now.
Cosine of theta multiplied by that, or cosine of
I'm afraid it will make sense.
Well, I guess I'll have to go to
That's a good question. This is
Hendrix or somewhere, I don't know.
cosine of 2 sine.
But doesn't 2 cosecant times sine just equal 1? How is it chain rule? Isn't it just
Mr. Townsend.
And you could run it out whatever
Brandon
way
won
you want,
the
probably,
competition.
as long as you set it
Oh,
up
yeah?
the correct way.
What competition?
Because he's not.
You know the cop.
I think it's really cool
Yeah.
that you're expected to sign up for every college ever within the first
Does he
month.
have,
Right.
does he have proof?
Because it's sine theta, and it's not sine theta.
Right.
Is there any proof?
Oh, cool.
There's no
And so you multiply that out, then we take the derivative of that. Just multiply it out. It's 2 cosecant times 2 sine is 2.
Executive function and those invisible weights.
I need to see the notes where she signed yes, I'll go out with you.
Multiply by cosine.
Brandon, get a note. Also, it's not that good. Yeah, so when you take the derivative of this, you need to make sure you take it with respect to time. So r becomes r prime, when you take the derivative of this, it's just create a theta prime.
What's cosecant times cosine equal though?
You being non-American.
You're shaking this. Wait, sorry.
Yeah. In Britain and Japan, there are high schools that apply to like colleges because.
Okay. That's just gonna give me Y prime.
Well, no, it's only certain high schools. It's like if you're going to like a super crappy.
Bring me my money and beat your ass if you don't
Yeah, there you
like
go.
it. I'm just kidding.
Yeah. And we know the derivative is cotangent.
How do you insert?
Whoa. Whoa, right.
Stitches?
Rate it. You can pay in other ways.
But in any case, the way application, which is giving me gross values now.
Right, that would be $10.
It's $10.
It's not nearly as bad as it seems.
But you can pay in other ways.
No, I think you know that's what exactly. I mean, exactly. Mostly it's no close.
Thank you.
And maybe
So tangent is 1 over the square root of 1
Also,
equals square root.
Yeah,
With that, then
Here's your
Derivative cotangent?
Yeah, I forgot 1, 3, and I was like,
I think.
so the derivative of cotangent is
minus
What do you
cosine.
think?
I knew the
Either would be great.
It's on me.
Where'd you find cotangent? Shouldn't that also be it's already in your Y prime? So it's already been taken as derivative though. So that would be taking double derivative.
X value though, so when you multiply 2 cosecant times cosine, it's multiplying cosine times 1/sine, right? Cosine over sine.
5 is this wrong.
5 is true.
Cosecant here.
5 is
Cosine.
What is the amount of work you have to do though?
I plugged in my calculator. It just makes it cosine.
So, do you know what the equation is?
Sine
Oh, so, yeah.
okay, so
Oh, we take a little bit of cotangent.
We're all finding the equation for the second derivative.
And that's negative 3 cosine. Negative 3 sine.
So it is.
I think we lost the
What's the
fire.
equation? Y prime over
I'm
X
just wondering if their expression is extreme.
And that's over.
Say that again, like 3 times.
This one's about.
How do you think you did with your test?
Well, I didn't know it, so.
When I get to
I'll be.
I still have not opened the text.
Thank you.
So I didn't know the shows kind of
One is fire and one is treatment and Philadelphia. Stop. So, clearly there's
I think it did go back.
or fire obsession.
I couldn't tell you.
I didn't know you had any of those. I picked one.
Yeah, I didn't even write anything down on my PC.
I feel like it's saying, it went up.
It's on the bottom.
Multiple choice though.
I'm just gonna write that on my paper.
I'm just
Negative
saying.
1.299.
They're good.
You put in the values on it.
Not yet. I've got Y prime equals 2 cotangent theta plus 2 cotangent theta plus 3 cosine.
Daylight signals.
Oh, it might be like 4.
Yeah, because 20 minutes into class, I'm like, hey, what? How's it already 10:10?
Yeah.
It's 11:05.
I'm disappointed.
You should have left class like
I was
45 minutes ago.
Oh, shoot!
The bells are ringing.
What I gotta get to lunch.
Yeah,
advisory doesn't end.
Advisory ends in another 25 minutes.
Don't you have a loaf of peanut butter sandwiches in your bag?
It's also very
We didn't bring any lunch or snacks today.
You should hear how your sister talks about you to her friends.
Who is it?
This shirt is
Is it not always freezing? We can be up on our phones.
It's always cold.
If
somebody
Discord
comes
is
in
based off of a character named Discord, but you would never know.
Gotta get one of those giant onesies.
Yes, that's right. I would.
He also gives us like a ton of games, like Mr. Townsend, like.
Like we saw.
He gives us
That was actually
Gavin actually like pulling out knows something about your girlfriend. That's gonna be one.
No.
So it's yeah. Yeah.
What's her initials?
Radical 2 or 2?
Piper, Reinhardt?
Those are initials?
You do?
Yeah.
She took pre-cal last year.
Oh.
good student, wasn't she?
She was a good student. I was nervous because she took regular algebra 2 instead of honors, but then she did well. Usually people don't do well when they jump from that to pre-cal, but
Minus 2 over the radical 2 is what we got.
Yeah, I realized that now. I realized that. What do you mean
I
I'm
got
cheating on
a lot more than that. I got
You know, it's actually
5.
kind of sad. Liam and I have a lot more
I got
dates
4 plus 3
than I have
radical
gone on with
2.
anybody else.
Yeah, we need to
That's
go.
like-
What was your numerator?
Liam and I used to, over the summer, Liam and I would hit up Penguin Heads like once a week. Yeah.
Whenever you were.
Sometimes twice a week.
You are the
We'd
X.
also hit up,
You wanna go to
All.
You should go to 9. We're at that. So you just did
I
3.
don't really want to go mini golf. I've been
I
out
did
to
4 cotangent theta plus 2 cosine theta.
What's your numerator?
My mom made
I guess your
$50.
yeah, your Y was
what?
What? I
My
thought
mom
we
had
had
50 pounds
going
of
back.
my neighborhood party thing.
We got the same thing that we took the derivative of, right? You got 2
It
plus
was
3
like
sine
25
theta.
pounds of meat,
Take derivative of
plus
that,
you
that
have
goes
to
away.
add in all
Three
of like
sine theta, just 3
beans and all
cosine
that
theta.
stuff. Just like cans and cans.
The only part that here was the cosine.
Yes.
That's washed and it's leftover.
No,
The normal time.
that was for the party.
Maybe it wasn't salty.
We ended up eating
Probably do this one.
4 crock pots worth.
Or you can finish on this if you need to, but.
We have like, you know those like
John's still
giant,
talking.
like the
I'll give you
giant
3.
Ziploc bags?
So-
I think we have like
If I
6
have
of
to
those.
prepare
just
my
full of
chicken,
sugar.
it is not worth going to get their chicken.
Don't feel like I'm.
So X prime of theta is gonna be 0, right?
X prime theta, you're saying X prime equal to 0. We thought that because you have a sine squared plus cosine squared, it would be never. But we were wrong. You don't factor it out. Because it's not. Because it's cosine squared minus, not plus.
Probably.
Cosine
You got
squared
3
minus
3 cosine squared.
22,000 grams of chili.
I might have done it wrong, because I got 3 cosine
What's got
squared
beans?
minus 3 sine
It's
squared.
probably
So
like
you got this, you got it. And then
I thought I factored it out, but you don't. You don't factor it out because it's still factored out as like plus. You got the negative
25 pounds of
Gotcha.
beef,
But
25 pounds.
I guess you don't factor out the negative 3 because then
because it make the cosine negative, right? Yeah.
Did you only
So
put
then
beans
what?
and meat in it?
and so
I thought it
then
was beans.
How'd you
Right,
solve
and
it?
then
You just
I realized
put
that's
it
worse,
in.
right?
no, we
Like
just thought about it.
potato,
It's whenever these
It's
values are
worse.
the same, right?
So
So
I
it's
was-
it's power of 4, 3 power of 4 because it's square root of 2 over 2, comma square root of 2 over 2.
We just buy cans.
Yeah.
At that
Yeah,
point,
yeah,
so it's
okay.
at all those points. And then apparently it's like
That would make it, yeah.
calculate thousands, 500 grams for the work when you grab
Okay.
it.
What, how do you know to take those out?
Just use the and then those don't
They don't work.
don't work out.
Bottles of cooking oil.
Literally like the entire
I want to regret all my life.
3
Except, I remember I told you, you were only doing so much
platter,
like shit.
half of it was
The
mashed
rest was just gonna run straight through ya.
Yeah. And then like literally like an entire cow's head. Like probably way more.
Sine,
Typical Tuesday ones. Yeah. Typical Tuesday. Some of those like the third one.
Makes me figure out what happened over these things.
Overrated.
I tried
I tried the
My
nachos
dad
at Central Barbecue like a couple months ago.
Maybe still has, I don't know.
You know, if I type in
One
one thing, how I can type something in at the
So
beginning.
like
And
in
asking
theory,
for-
Don't.
it's better at Central Barbecue, but the queso at Central Barbecue is
Kind of is.
horrible. It's like the
With chilies on
it's like the
side.
queso you get at like
Huh?
the football.
Mr.
games.
Townsend, do you-
like it's bad.
If I type in this whole equation, do
So
you know
just
how I
like
can
this
go
ratio.
back in
It
and
just
type
gets
something in
confusing.
front of that equation?
Yeah, it's barbecue sauce.
is like the best barbecue sauce.
True.
And like the main thing is
Yeah. I think the meat at Central Barbecue is a little bit better.
Is that
And they put like seasoning.
Or- Which one did y'all cross out?
They put seasoning on the.
5.7 pound.
It was
Okay,
like
guys, y'all have about 8 minutes. So if you are not going to get these 5 questions finished and to me before you leave, that needs to be your homework. Also, you need to do at least a question or two from assignment 36. I'm expecting you to make some progress on that. I won't ask for 36 to be picked up on Wednesday, but again, you need to be making progress on that so that it's not too much when I do ask for it.
So, Mr. Townsend, number 38, can we get that into next class? We're struggling on one of these problems.
Yes, as long as you give it to me at the start of next class, it's fine.
Just working through.
We're not struggling at all.
Went right past.
We're just taking extra time on them, that's all. We're struggling. I'm struggling. I don't know about these guys. I don't know about these guys. I don't think I'm struggling. I'm struggling.
Which one are you on?
3.
I was
the easiest one?
for a while.
No, 3's the hardest one by far.
Why?
Because too much math.
I don't know how you eliminate certain answers whenever you graph it.
Yeah, how do you do that?
So you graph it, and then you look at the graph, and then you see that there's only 2 vertical tangent lines.
Oh, I need to graph it.
So like this, little graph. There's only 2.
That's not the graph.
That's
It
not right.
goes like this.
You graph the derivative or something.
I'm not supposed to graph the derivative.
Are
Oh,
you supposed to graph
I'm supposed to graph the normal.
Oh.
There's 2 times where it's vertical tangent lines, so you have to figure out which of those angles are at those values.
How do you find that?
Well, it's let's guess one. Pi report. So hit trace pi report in there to jump to that point.
Trace
24, maybe 36.
and trace, and then I can hit power.
Pi report. Down there, and then jump to that line. Is that where vertical tangent line is?
Yeah.
Okay, do that one.
And then I'll do trace,
I did like.
I gotta.
a good
trace,
couple more
3 pi over 4.
Actually, mostly I just watched Get 15
And then the other, okay, and then the other.
So you know it's not the other.
every once per hour.
Why do you even have to know what that R equals F?
Did anybody come up with an answer to the puzzle?
7.
Yeah, you just do that.
42 is correct.
I'm literally plugging that in my calculator.
Why do you even have to know this?
42.
No, this is the thing that
Because you just take it.
Oh, this is saying that you can't plug in your calculator.
I do have a solution video for this, so I'll put that in Google
That's
Classroom.
unnecessary information, right? Because all we need is the dy over dx, dx over dx over d theta. Perfect.
Yeah,
And then plug that in, right?
that's what it looks like to me at least.
in any case, I'm not really that interested.
No faith in me whatsoever.
If you're interested in the answer or the explanation to the puzzle for today, it's in Google Classroom now.
Is it 42?
It is 42.
Yay.
Yay.
I'm gonna check our answers on the calculator.
Because do you know anything about the Hitchhiker's Guide to the Galaxy? That's the entire question.
I read the page.
No. It's like they made a supercomputer. It was what is
Oh,
the
there it
answer
goes.
to the universe and everything. The answer was 42. But then they go through to find out what 42 meant. And then Earth got exploded. So the and that's all I know about the Hitchhiker's Guide to the Galaxy.
Yeah, experience. I started reading up the data after
Q.
Yep, thank you.
I guess if you can watch the movie, the Earth exploded. Yeah, there's a movie. But they exploded the Earth and I got scared.
Yeah, that's
I was
pretty
like
awesome.
4 or 8.
It's not bad.
Yeah. And still lived in Paris, so it was a long time ago.
Sorry.
I play horror games now, and I used to hate even watch like multiplier videos. I have to cover the screen and just watch the base case.
It's just like when you,
But now I
you know when
have
you
like
like plot stuff with polar stuff, the radius is the y value when you plug in theta. That's all that says. R is the y value when you plug in theta. That's standard for all.
So all we would have to do is plug in
I
that.
tried to play Resident Evil and I had a
The
very bad
first one
time.
was, the one second.
I thought, oh, but then you take the derivative of that, and then add 3, right, in your calculator?
And you have to divide it by right.
Right. So that's,
So,
that.
how about that?
All of this, the derivative of all of this
It's
is
awfully cold
the
in here, aren't
derivative
you?
of
Cold?
dy dx.
I kind of like the cold. I know some
And,
people.
what you're is 22 dy dx. When you take the derivative of that and divide all that by x times x squared, you have to divide by x times x times.
Calculate the volume?
Just like you do with vectors of
No.
parametrics.
I successfully calculated it.
Yeah, it's 42.
What about the volume?
My parameter is gonna be the, you count it all up and
You don't like it?
I don't know, I haven't had time.
It's not volume anyways, Oliver. It's two-dimensional shapes.
Yeah, it's good for us.
It's area.
You don't so plus 9. Plus 9. Wait, are y'all still? Are they still gonna stop like buying these light bulbs? Or
But where are these poles?
I think they've backed off to that, I don't know.
after they got everyone aboard?
Well, nobody was on board.
Oh.
As far as I know, there's only a couple of teachers in the entire school that would
Stop this.
prefer to have that.
Oh, really?
Prefer to have it.